Hi everyone. Most importantly, thanks for coming over. I'm Blessin Varghese and I work at Bajaj Finserv Health. Now for starters, I'm pretty sure everyone knows Bajaj Finserv, right? So for the right reasons or the wrong reasons, we are India's largest NBFC, non-banking financial corporation. Uh, Coming to stuff, we are worth over $70 billion at the group level. So that's Bajaj Finserv. So what is Bajaj Finserv Health? We are a new startup from the house of Bajaj Finserv. We deal with preventive cashless health ecosystem. If you've been to US, you might know, right? You don't pay there. It's pivoted by insurance. So that's what we do at Bajaj Finserv Health. So I am from SRM, Chennai. I did my engineering there. I'm a pass out of 21. So you're also from SRM? All right.
21 pass out.
Okay, 21 pass out. Okay. All right. So this is Bajaj Finserv Health's homepage. Now, quick interesting thing. You see the search bar over here. You see this is a listing page where you see list of doctors. This is where you see list of lab tests. You see insurance. You see hospitals. All these things. The most interesting fact is that all of these components are powered by Elasticsearch, right? All the top features are completely powered. So I am an evangelist of Elasticsearch. I try to over-engineer just so that I can put Elasticsearch in the system that I design. Sorry, so I lead backend and app engineering over there. So in backend, we have almost all backends coupled with Elasticsearch. For the right reasons or wrong reasons, we have Kafka and Elasticsearch everywhere. Right, so this is our primary use case. We have elastic observability. Obviously, every single API, even if it's an in-house one, it's a third-party one, no matter what we write, every single thing goes through APIM, APM with Elasticsearch. I mean, the entire elastic observability setup. Then we have bots. I mean, this session in particular is about vector search and bots. I won't be covering a lot about observability because that's the de facto standard for all sessions. Then we have data analysis and search. So we'll stick primarily to bots because this is about Gen AI with Elasticsearch at BFHL, Bajaj Finserv Health. Right? Guys, see, in our company we say insurance is the most boring business to do. At least in India, we don't buy insurance because we need an insurance, right? Think about your motor insurance. Why do you buy motor insurance? Otherwise, the cops will catch you up, right? You'll have to pay a challan. Why do you take the health insurance? Because it's rather forced upon you. So selling insurance is tough for us. What's even tougher is processing claims, right? Let's say you over there, you raised a claim saying that I broke my arm. Let me make it better, right? I broke my arm. And someone else says, I broke my finger. And the first one told me I need 1 lakh rupees for fixing this. And the second one told me I need 2 lakhs rupees for fixing my finger. Now, we at Bajaj Finserv Health, we process lakhs and lakhs of these cases. Now, it's impossible for us to assign human agents and tell them, go through each cases, approve, reject. Now, imagine, you make one wrong approval, you lose a lakh, or maybe 50,000, or thousands of rupees, right? So we've automated that using Elasticsearch. Now, spoilers, we are still at very early stages of implementing Gen AI, vector search, and all this stuff at BFHL. So we might have done it the right way, and I'm open to feedback from you on how do we improve it as well. Yeah, so what do you mean by insurance adjudication? Let's say you raise a claim. When I say you raise a claim, you tell us, hey, I went to a hospital. Now you have to give me 50,000 rupees because I did something. On an average in India, I mean, you can go to this link or scan the QR. On an average in India, our competitors take 20 days to say yes or no to your claim, whereas we take 4 hours. And this entire process is powered by Elasticsearch. I'll show you how do we do that. And this is industry standard. And I mean, our competitors are trying hard to match with us, and you can go here to read more.
What is the claim settlement ratio in the?
It's above 92%. So we don't look at claim settlement ratio. We look at true positive claim settlement ratio.
Correct.
So it's above 92%. And it's open public data. We have cashless and reimbursement. For cashless, you don't have to go through this. Because you come to our network, we provide you service. This comes only when you go off network. And sadly, in India, in the US, cashless is more prominent. But in India, we still haven't reached that level. But in the next 5 years, we'll make sure India reaches there.
But even in cashless, you have adjudication. Meaning, just because you did cashless, not every claim.
Sure. So this comes with your policy details, like the policy that you take. For example, there are certain policies which says up to 5,000, we don't look at your claim. We'll just approve. That this is highly specific to the product that you hold.
Right.
So even in cashless, there are cases with adjudication, without adjudication. You're right. But let me not give you an insurance for our masterclass yet. That's for a later day. See, this was our process of insurance adjudication exactly 1 year ago. I'll quickly go through this. Yeah, so this is us, a customer. You raise the claim. We used to follow a maker-checker process. The claim was raised by the customer. It goes to multiple levels. Overall, we have an agent or expert panel of agents depending on the amount that you claimed for. We manually go through this, and then we say yes or no. Now, there's a big risk associated with this. Let's say Ashish and I, we are brothers, right? Ashish broke his arm. And I know, right? So Ashish broke his arm. He raised a claim for 1 lakh rupees, and since it was a true positive claim, we gave him 1 lakh rupees. Fine, good. I saw this. I took the documents that Ashish submitted. I just changed the photo, the name, and the policy ID. And I submitted back for 1 lakh rupees. Now, if it goes through manual intervention or human agents, it's very likely that they'll approve the claim because it matches every single rule that's required to pass the claim, right? Now, we as the company, we lose 1 lakh rupees right over there. And this is impossible to tackle using manual process. So we implemented vector search over here. I think the CIO of Airtel spoke about this yesterday for images. So what we do is all of our past claim documents are converted to vectors, and we do a similarity check. The moment you submit something, we run it across all of our historical data to check, do we have a document that's very similar to this? Then we show that to the agent. See, this is the submitted document, but I found 3 more documents which are very similar, right? And we have caught a lot of cases, like 15 to 16%. I mean, that's a big number, it's not a small number, of cases which were fake. And all, again, just through Elasticsearch. And just over here, last year we used to take 48 hours to say yes or no. I'll quickly move to what do we do now. Yeah. So the moment you submit the claim, it doesn't go to an agent. Rather, you see this hexagon over here? This is 100% built on top of Elasticsearch and Kafka. Right? I mean, I've told you, right? Whenever I build something, I make sure there is Kafka, there is Elasticsearch. It helps. Otherwise, it will help sometime in the future. And trust me, Elasticsearch and Kafka are a match made in heaven. So yeah. So the moment you submit something, you have a risk score. I, as a person, consider this to be similar to your CIBIL score. This is an internal profile that we built for you. Syndicate analysis, this is the one that I just told you. Duplicate claims. Do we have a similar claim document from the past? OCR for a lot of other stuff. SOP is exactly what you just asked me. Does my policy support this claim? Right? More on that later on. And then medical knowledge base. Do you actually need 1 lakh rupees to fix a scar on your arm? Right? We have in-house document search for that as well. And then we reduced 48 hours to 4 hours. Now you have to understand, for us to be the market leader, it helps us outright edge over our competitors when it comes to number of claims processed per month or per day. All right, I will skip through this. This is nothing but the vector representation. It just talks about how do you convert input to vector. Now, consider this. See, in insurance, the biggest question is, will my insurance cover this? So we built a bot. I mean, if you have a policy from us, you can actually go to our website or our app and can ask, does my health insurance cover a bungee jumping accident? Right? This is not a POC, this is deployed on production. This went live like 2 months back. We still have a lot of errors and false positives here, but we are still improving on it. I'll just show you. So this is a very high-level overview of how this works. We have data coming in from here. Now there's something called as tokenization. For starters, tokenization is nothing but breaking down of your data. Then, OpenAI. For the time being, we work with Azure AI, Microsoft's Azure AI, because we at Bajaj Finserv, we are fully on Azure. We break down, so vector embedding is nothing but converting your English to numbers, right? French goes to numbers, English goes to numbers, Hindi goes to numbers. It goes to vector embeddings, and we store it in Elasticsearch. We tried something called as Pinecone. I hear people calling it Pinecone as well, but I call it Pinecone. We tried that, we tried MongoDB, we even went to that extent of trying PG Vector for Postgres. But then I came in, I'm like, let's try Elasticsearch. And bam, Elasticsearch worked very quickly. There is semantic search for vector embeddings in Elasticsearch inbuilt. You don't have to know how it works, it works. Then this is how the user queries it. I know this is an architecture diagram. We'll see a live demo of how this works. Now, for starters, this is how you write a vector embedding query. You don't have to do it. There's a tool called as LangChain. We'll go through that. But this is how we start. We represent documents and queries as vectors. Whenever you hear vectors, just consider it as an array of numbers in a high-dimensional space. Now, how do I say these two are similar, right? For people who are not into maths, see, these are vectors, right? What is a vector? Vector is a line with a direction, done. Now, in this Cartesian plane, in this quadrant, the closer the angle is, the more similar your objects are, right? It's a very rudimentary example now. Mathematicians in the house don't cross-check. But, the closer this is, the more similar the objects are. That's it, right? Now, probably if I put a car here, the car would come somewhere over here. Fine. And again, when you hear vector, remember text to number. Due to shortage of time, we'll come back to this at the end if we have time. But this is nothing but a cosine similarity between a car, a bus, and an insurance. Because we keep saying similarity search with Elasticsearch, OpenAI and all, but it's very fundamental to know what do you mean by similarity, how does cosine similarity work, BM25, or whatever you use. We'll come back to this at the end if we have time. And definitely, this is the cosine query. And discount overlaps is nothing but a parameter in Elasticsearch to discount your overlaps of document similarity. Yeah, and then we come to scoring. I'll show you how do we come to scoring. When we write the Azure AI query, there are two things. One is the system prompt, one is the user prompt. This is the most important part here to prevent something called as hallucination. You can have the smartest model, but if the model starts to think on its own, your insurance company will shut down, right? So this is literally the exact query we use on production. The system prompt is understand the insurance document related to a user's insurance cover query, provide response strictly in JSON. Now, if you see, Sam Altman announced they have a strict JSON mode in OpenAI, but this is how we implemented that. Provide response strictly in JSON, works. Categorize the decision made between 3 states. And what are the states? Covered, not sure. This is very important. You can't ask it yes or no. You have to give it the freedom to say, I don't know, right? And for the following, this is nothing but the user's metadata. And then what happens is, using vector search, we go through all the policy details that we have from our sales database. And then it tells us that then we send those vectors to OpenAI, and it's simple. Hey OpenAI or hey Azure AI. This is the policy detail, and this is the customer's requirement. Can I fulfill this using this? Can I fulfill his requirement using his product metadata? And it says, bungee jumping accidents are not covered under the standard health insurance policy and all those stuff. This comes from a document. But you can't send it back to the customer. So we send it back to OpenAI to rephrase this. And OpenAI tells us, this is the decision maker. Is this covered? It can tell us it's covered, not covered, or not sure. What happens if it's not sure? We forward it to a manual agent. Obviously, the turnaround time would be higher, but that has to be done for the time being. And we also have this cross-selling plan where it says, however, an upgraded plan may provide coverage for such incidents. Now we are working on a system where this recommends the exact plan. So you buy this and you get that. Now this is the most interesting use case that we built last month. This again works on top of vector implementation of Elasticsearch. So this is our brightest feature. Our bots will never say thank you when you write a complaint to us, right? I'm pretty sure you have come across this situation. I've intentionally covered this, but this is a screenshot from the most popular food booking application in India, right? If you get it, you get it. I don't know to call out the name. The customer kept complaining, and this is on Twitter. The customer kept complaining, and this is a bot. The bot told, thank you for connecting with us at the startup or whatsoever. I'm glad to have helped you. Whereas the customer is super frustrated. Guys, even though this looks like a product issue, this is a misconfigured bot. That's it. Because the bot is configured to look for specific keywords and answer. So how did we solve this issue? This, as all of you know, we built cognitive capability using LangChain vector database on Elasticsearch, obviously rulebook and guardrails, and Azure AI. And sources can be anything because it's a REST API. And we went forward to provide or build a drop-in replacement for Salesforce Einstein. I hope you have heard of Salesforce Einstein. It's an LLM from Salesforce. So we built our own implementation inside Salesforce. But let's move forward and see how does that look. This is the production implementation inside Salesforce. So for people who don't know what Salesforce, it's the world's most popular CRM and very prominent in big businesses. So this is a drop-in replacement for Salesforce Einstein at less than 95% of the cost with the exact same functionality. Now there are two use cases to it. We have customer support agents. So my customer's name is GB and I'm the customer support agent. GB called me up and asked me, hey, can you tell me about my past claims? Now the agents are not PhD holders, right? They have their own limitations at their own levels. So we built this bot where the customer support agent can just click on his profile and type past claim details. Now please note, the prompt doesn't include any of his data, any of his policy details or anything. The context is fetched from Salesforce and all those processes we saw in the last couple of slides. And then the bot tells us, these are your benefits, this is the status of your claim and all those stuff. Now we went ahead, tested it for 2-3 weeks, saw it's working good, and we deployed it for our customers. We call it the Health Sathi bot. Now this is how customers are using it. What are my policy benefits, right? And the bot tells you without any more questions, these are your policy benefits, right? Now the technical part over here, it understands I'm not providing an OTP, I'm not providing my UID, nothing. It understands the context and response. Where does this data come from? Elasticsearch. Now this is the same example. It's a fractured bond covered in my policy. Same thing. Now this is hyperlocal. So we have geospatial data indexed in Elasticsearch of all our network partners. And when I ask labs near me, it first figures out if your policy covers labs, then goes and fetches all of our network providers in your area and responds with a simple text. And trust me, this to be done over call is at least a 20-25 minute process, which is solved in less than 10 seconds here at almost no cost because you have to pay an agent to do this. This incurs only with the cloud cost and the open Azure AI implementation. And then I can also ask, hey, I have a policy, but who all from my family are covered? If you're into insurance, you might know, some policies cover only your wife or your spouse or your parents or your children. So, and we do get a lot of complaints for this. So this bot covers that as well. And all this data comes from Elasticsearch. I'm not going to go in depth into it, but we are a big fan of real-time search. So we used to use, there's a provision from Microsoft called as App Insights, Azure App Insights, and that used to cost in lakhs. And then as the organization grew, the bill also grew. And then we figured out, all right, we have to put a stop to this. We can't keep paying Microsoft a lot of money just for logs, right? That's when we started a project internally. We took all the offerings from App Insights from Microsoft Azure, jotted it down, and built a drop-in replacement for App Insights using Kafka, because we have logs coming in from everywhere, right pressure. Kafka, DBCM is a CDC tool. I'm not going there. Kafka, DBCM, SQL, and Elasticsearch, obviously with Kibana. Also, we have lab data coming into our ecosystem. And let me give you an example. Let's say I did 40 lab tests over the last 5 years. Now I have a requirement of figuring out those lab tests which told me about my blood glucose levels in the last 5 years, right? No solution in India today tells you except from our side. So in our side, in our app, if you push documents to our app, you can go to lab test documents and you can search blood glucose levels. Our system will go through all of your PDFs, figure out which documents have these terms, and then show it to you. To give you numbers, we had 1.35 million documents come in this month. This might look like a small number, but health digitization in India is still a very big challenge. You might not be seeing it. It's not as simple as pushing data to Google Drive. It's a heavily regulated field. Like if we collect a document, we are answerable to the government. How do you store this? How do you make sure sensitive PI is removed and all those stuff? And I have to show you one more thing, quickly. Yeah, I'll take question. Give me a second. So if you look at this is the drop-in. I mean, it's a simple Kibana dashboard. While that's loading. So if you have seen Azure App Insights, this is the dashboard that Azure App Insights provide, right? These are the manufacturers. This is production, guys. You can see ELK-Pro, right? So App Insights told us these are the manufacturers of the common devices that your app is being used on. This is basic logs. There's nothing rocket science in here. But we compared it with App Insights, and this is 98% cheaper than Azure App Insights. And then I can drill down. I'll show you. So if I click on Samsung, this is basic drill down. Not again, zero rocket science here. The entire dashboard gets optimized for Samsung devices. And we now are able to figure out any issue on any device at any point of the time within less than 10 minutes with complete logs. If you go to Discover and Span, you'll get the exact RCA. This JavaScript line caused a crash due to this set of execution, and this is how you figure out the RCA. And then, now you would say that that's for tech. No, we made replacements for common product requirements as well. So this is our FUM, MAU, and all those stuff. Again, stored on Elasticsearch. Just want to share it with you because we cut down 98% of the cost moving all these reporting to Elasticsearch. Yeah, now open for questions. Yeah.
So you said for the blood glucose example, right, it will scan through the PDF. So would it index all of that data inside Elasticsearch? That's like the first question. So is it only using Elasticsearch there?
No, so it's not just Elasticsearch because for health data, we have something called as Loink, HL7, SNOMED, these are standards. Because vendor A will call it blood glucose level. Let's say Thyrocare. You went to Thyrocare, they'll call it blood glucose. But when you go to a different lab provider like Apollo, they might not call it blood glucose, they'll call it blood glucose level. So we standardize data. So it's like key value mapping. All blood glucose synonyms are mapped against a standard code. Then that's pushed to Elasticsearch. That's how you can track across providers. And even the units differ.
Yeah. And right? How are you handling the removal of the PID data?
So I can't tell you right now, but that's a very rudimentary Python script with a model attached to it. So we manually reviewed PI coming in for first 3 months. We figured out, these are the ways in which PI comes in. We kept improving our model back to back. Now we have a model which, when fed with a PDF, can give you the same version of the PDF without any PI data.
So you're not using masking inside Elasticsearch?
Because if you mask, the data is still stored. It's just that it's not exposed.
Remove
We don't want data inside Elastic. I mean, not just inside Elasticsearch. We don't want customers' data to go anywhere. Because tomorrow, if the customer says, "Hey, delete my existence from your platform. I don't want any of my data to be stored on your servers," then it's a tough job to do if we mask it.
Blessin, you're doing the hybrid search or just a vector search
Where?
while performing the
So it's
semantic?
hybrid search. The reason being we have policy details. Policy details
Yes,
are
that is
policy details is not something that you have in
Yes,
vectors.
exactly.
So that's straightforward normal search, semantic search. Then your policy details from the documents are vector search because that's where we compare for similarity.
All right. And one is, as you showed the hospital near me.
Yeah.
So of course that query is a geo shape query.
Yeah.
But how you converting this string into the query DSL?
That's a very interesting question. In fact, we spend a lot of time figuring this out. So when you enter something called as hospitals near me, it first doesn't go to LLMs. First it goes to NLP. And there's something called as intent entity extraction, right? And intent is lab search. I mean, these are internal to us, but the intent is lab search. And subject is again me, near me. So we replace me with the UID, right? So it's like lab centers near one customer number 1234. Now this again gets converted to we replace customer near to the actual address. So it will be lab centers near Bangalore, Karnataka, and then it goes to lang chain and all those stuff. Yeah.
So when you talk about the geo search, are you also going to extend it to the location of the device itself rather than go to the address that's
I think that's a great feedback.
latitude and longitude.
Yeah, currently what we do is we take it based on a policy address. Let's say when I bought the policy, I registered it in Chennai. So the entire near me feature works on Chennai area. But great feedback. I think we never thought in this direction. But to build this as well, it's a one-day task for us. Replace policy address with device address. But yeah, thanks, Rishi. I'll
As a
take that
customer,
forward.
that's what we would be
Yeah,
expecting.
yep. So
Because
yeah.
the person might not be in the place where
Yeah.
he bought
Sure.
the
So,
policy.
I mean, as I mentioned in the beginning, this is a great feedback, product feedback, I'd say. I'll take it to my team and I'll update you once we implement this. So that when you buy policy from us, you can do the same search on our apps.
You can enrich it with
Yeah.
latitude and
Yeah.
longitude search. You can add open maps into it
Yeah.
as your Google Map API.
Yeah.
As you mentioned that you are using the Kafka in across this functionality, right?
So sorry, Kafka. Yeah.
I would like to know that how you're utilizing the Kafka in the across the search. Like,
So at BFHL, what we do is we have this concept of data mesh. We follow a strictly distributed systems architecture where we are aware of, I mean, we don't like REST APIs internally, right? So all of your data across teams gets pushed into central Kafka system. So that when you want, let's say we three are of three different teams, he needs my data, but my data is dependent on him. So in a rudimentary approach, first he'll call a REST API to my API, I'll fetch his data, then I'll shape it and send it back to him. In our organization, what we do is, he'll push data to Kafka, I'll shape it and push it again back, so he fetches it from here. And we control it with RBAC, who can access which topic. So it's like data mesh. All of your data is available to anyone who has the right privilege. This is faster, significantly faster. APIs take around 50-60 milliseconds at the backend. This brings it less than 5 milliseconds, and the cost is also very cheap. But the only thing is you have to think through when you architect for this.
But again, Kafka will be fed to directly to Elasticsearch, or is it?
So we have connectors. So for Elasticsearch again, Confluent provides something called as Elasticsearch sync connector and source connector. Source is when Elasticsearch is your source. Sync is when Elasticsearch is your destination. So in this use case, we use sync connector. So we don't have REST APIs in between them.
So the PI information is being shared from app. So will it reach to Kafka, or the app itself?
So in Kafka, we have Kafka rules. So using Java, you can write plugins for Kafka, and that's where we remove PI. So if you ask me, does it reach the VM? Yes, it reaches the VM or the instance where Kafka is running. Does it stay in the queue? It doesn't.
Because as you mentioned, there's a
Got
model.
it. Yeah, so it reaches the VM. Definitely it has to reach somewhere, right? It comes to our API gateway, yes. Comes to our instance, yes. But we remove it there and it doesn't get stored anywhere.
If it is a straightforward key where the PI information is being fetched, then it can be dropped in logs.
Absolutely, yes. But the issue is it's not a straightforward key. A customer from Apollo hospitals and Manipal hospitals will have two different types of keys. And then we can't say we are limited to 5 hospitals. We support all hospitals in India, from a village to tier 5 to tier 1. So that we can't set a rule-based approach there.
But that also you could have done in